Hello guys, how are you? And I hope you are fine and welcome back to the YouTube channel of The Concept Guy. And today we have the Barc 2021. Barc is Bhabha Atomic Research Center that is in India. So it is Bhabha Atomic Research Center and it conducted an exam today uh, of 2021 in 2021 for people who want to apply for OCES or DGFS. So the exam was conducted today, as many of you must know. So, and today itself, uh, I'm going to tell you about the questions and how it was and what would be the cutoff marks and many more discussion on this paper. It was an online paper, a computer based paper actually, where we had to go to the center and all the details you might know. So it was Barc paper and it doesn't release its questions. The paper question paper isn't released, so there is no such material so that students can prepare for it. So that's why I thought that to bring up the questions, whatever memory based I remember, and I hope this will help not only the candidates of 2021 but also in future if someone needs it. And I am going to tell about the chemical engineering questions. So I also just encourage other branch people also to post the questions, because that will help the coming uh, then in the next coming years many people who want to just give the exam. So stay till the end because we are going to discuss the questions and some of their answers, solutions. So I might be wrong in remembering the question, and even I might be wrong in some of the solutions. It can be it not that in all, but can be. So it's uh, okay that if you just comment and correct me, and I will be really appreciating that, because that will be really beneficial. I am a human and not a machine, so I don't actually remember the whole question exact same, but I remember most of them exactly same, because a few hours ago only I gave the exam. So I hope, let's begin. And you can just always comment and like, share and subscribe as always, but the main thing is that you can also comment the questions and the possible answers, or the answers you feel are correct. So without delay, let's begin. And in the end, I will tell you about the expected cutoff and how the response was of the students present in the center, and about some center difficulties and center experiences. So that's for later. Let's move on to the question. So question number one. Uh, it could be in any order. I hope you are able to see this question one. So let's start with heat transfer first. So, or let me just tell you the questions one by one. So first question, the simple question is that Smith number corresponds to which number, which dimensional number in heat transfer? A very simple question, and the answer you all know, Prandtl number. Okay, it was MCQ, the whole question was MCQ, so it was simple question. The next question was that then in natural convection, let me write it, natural convection, what there were four options given, and which favors the most. Okay, so one of the options were the delta T, one were like viscosity, I guess, viscosity, one was density, no, that density. um, so these were some of the options, and I feel delta T the temperature gradient, increase in temperature gradient will increase natural convection. You can just feel free to write the other options in the comments if you remember. So the next question was question third, that was a plot was given, k is equal to k naught 1 plus alpha t, and here alpha was given less than 0, so there were different curves of k, not of k but of t versus l, t versus l. One was like this, one was like this, not like this, a little bit like this, one was like this, and other something. So as we know that it is less than 0, we know that k will decrease because it will become minus, so k will decrease, so delta t, the gradient dt by dx will increase, hence the slope is going to increase, and hence we can select the correct plot with this. Okay, now the next question, fourth was forced convection. There was forced convection, question on forced convection. Here they asked that the change of laminar to turbulent is uh, is known by, I hope this writing is okay, turbulent is actually known by which dimensionless number, dimensionless number. So there were very different options. Now I will give you two options and you need to select. One was Rayleigh number. uh, Rayleigh number, I guess I should write is ry, let's say. Rayleigh number, let's write it Rayleigh number. And one was Reynolds number. Okay, and there were other two options as well, but try to think over only these two, what could be the answer. I think that Reynolds number is laminar to turbulent, but in case of forced convection, Reynolds number is now guided with Rayleigh number. What do you think? I think Rayleigh number was the answer. Anyways, you can comment that also. uh, okay, but I'm just telling the question so that it helps you, and many of you might even remember, and we can discuss it over in the comments as well. Don't worry. In next question was pretty simple. So this was a very typical question where we were given three slabs, let's say three slabs, they were different materials, and the thermal conductivities were given 1052. The this distance thickness was given 300 mm, that I remember. This was 150 mm, this was 100 mm. So, and this, I hope this is visible, this was 1000 at 1000 degrees Celsius, and this was at 50 degrees Celsius. You need to find out the, I think the, this temperatures, the interface temperatures, and the options were very much different. All options were different, so find at least, let's say you find this temperature at this interface, then you can easily find, no need to find this temperature. Okay, the procedure is simple. Let me write it, that q is equal to delta t. Now let me just show it directly, or it will take uh, time. So it would be like, we take 1000, it resistances in series, so 1000 minus 50, I hope this is visible, 1000 minus 50 divided by, this is actually 0.3 meter, this is 0.15 meter, this is point 1011 uh, 0.1 meter. So 10, so 10, this is 10 5 2, so this is 0.3 divided by 10, this was 0.15 divided by 5, and this was 0.1 divided by 2. this would be equal to let's say take any temperature. Let's say this temperature is T uh, BC, this was TAC, AAB, sorry, this was TBC. Let's say TBC uh, minus 50, and the resistances will be this. So 0.15 by 5 plus zero point 0.1 by 2. So this way you can easily get that. Not a difficult question, just a bit lengthy because you have to do all of these calculations. Okay, now the next question, question 6. Let me just make a marker. So question 6, this was about that we were given a pipe, a cylinder. So here it was like this. So there were two areas, inside flow was there and an outside flow. So there was some HI, let's say, and HO. So different areas are there. Now we need to find out the overall heat transfer coefficient. So there were two overall heat transfer coefficient, U1. This was based on outer area, AO, let's say O is out. Okay, so outer area, and 1 by U2 that we need to find, that was on based on inner area. So because both can be there, so the outer area was given, we need to find the inner area heat transfer, overall heat transfer coefficient. So this was quite easy, but again some calculations. So the outer one was given as 200, and we can write it as 200 is equal to 1 by H naught plus the, now the let me draw it better way. Now this was 30 and this was 33. So 33 outside diameter and 30 was inside diameter. I guess it was in millimeter. So after that, so this is the way we do it. 1 by H naught plus 33 by 30 into 1 by Hi, and the other equation will be that 1 upon Ui based on inside diameter, or we can say U dash. Anyways, we need to find this quantity, and this would be 1 upon Ho into these are the radius. Okay, so these are the radius. So now this comes up here 30 by 33 plus 1 by Hi. Now a very easy way is to just move these over here. So 1 upon U dash into 33 upon 30. What it is? It is, if this goes up here, this goes up here, this quantity and this quantity are same, so it is 1 upon 200. This way you can find out U dash or anything, the overall heat transfer coefficient based on inside area. I hope this was clear. Seventh question was simple Froude number. Froude number is actually inertial force upon which force. So there were many options, and the right answer is gravitational force. Next, there was eighth question. I am running quite fast with questions because I have to cover a lot of questions. So you can just move back and see if you just want it in slow version. So there was given a Q of lube. So lube oil heat was given, and they were given into rho V into rho V. Yes, let me write it, rho V Cp delta T by time. So this was volumetric flow rate, and this would be equal to a kind of question. I don't remember the values because there were a lot of values. This was, I guess, 2.13 around lubile. This was around 865, I don't know exactly. So this was the whole thing. Let me tell you the concept actually, that matters. So this was basic heat transfer, that Q is equal to Q lubile is equal to rho V Cp delta T upon T. This would be equal to the water jacket, the water that was flowing, the same heat, and this was also same, but we need to find this V upon T, that is the volumetric flow rate, Q dot. That is what we had to find. It was simple calculation. Okay, not much lengthy. Now the next question would be the next question would be 9. That would be there was given that some amount of uh, energy was incident on a surface where the alpha is absorptivity was 2 times of transmissivity, and it was 2.9 times of reflectivity. So we need to find out the area. A is equal to alpha q, that is how much was absorbed, and T was equal to tau q, how much was transmitted, and same way is the reflected one. So a basic relation, let me tell you about the basic relation. A basic relation is that alpha plus tau plus rho is equal to 1. Now we have alpha, now we have tau is equal to 1 by 2 alpha, so alpha by 2, and rho is equal to alpha by 2.9 is equal to 1. We get alpha, we get tau, we get rho, we get A, T and R. Simple, just calculation. Now the 10th question was 10th question was kind of same, like the cylinder was given, but here now what they did is that they took the inner H no Hi, they took the K value, and they took the outer heat transfer coefficient and told us to find out the overall heat transfer coefficient based on the outer area, I guess. The values were given. I particularly don't remember the values. Sorry again. If someone remembers, then just tell in the comments. 11th question was Inokel Inconel Inconel Alloy. So what is a major constituent element in this? And that was nickel. Inconel nickel Inconel nickel. I hope this sounds quite same. Inconel nickel. So I hope you will now never forget it. Anyways, let's move on because we have a lot of questions to discuss, guys. Seriously, there was question on annealing. This was a, a pretty like different question for us chemical engineers, so you can study this uh, topic. I especially don't even remember the question, so but this topic also came, so you can take into account. So 13th question was on rusting and galvanization. Now one thing there was something like if presence of oxygen will lead to rust. That was right, and I think all the options were right. I don't remember exactly, but galvanization is a cathodic operation or not, this was also asked in one of the options, so think over it. Galvanization is Zn, so is Zn prevents Zn zinc is prevents the rusting. Okay, so now 14th, uh, so material, what is that type of material that doesn't break, does not break at the fracture point? Will it, now I will just give you two options here. because two options were among them. It was difficult. There were four options, but I hope I just remember these two. One was malleable and one was ductile. So at fracture point, uh, malleable is like thin sheets and ductility is like the wires. What do you think uh, will not break? Okay, think over it. Okay, which material will not break at the fracture point? Thin sheets and wires. Think now, what will not break at fracture point if you apply too much stress? Okay, then which will not break, wire or sheet? Okay, now 15th, uh, q q is now I'm moving to fluid mechanics. So there was this that in orifice meter, the pressure difference varies on q raised to power n, which on which thing. So we know q was like a1 a2 this kind of stuff, and under root delta p by rho something, this was there in orifice meter formula. Okay, so qi, it should vary with delta p under root, that means delta p should vary with q square. Okay, so in orifice meter this was the thing. Next, the question was asked, 16th question. Uh, it was a great gate previous year question where pumps were added like this. Uh, these are centrifugal pumps, and this point was h1 head 1, this was head 2, this flow rate was q by 2, q by 2, and the head relation was given with respect to flow rate as h is equal to a minus bq square. This is the same gate. This has been asked in gate as well. So there were many options. Now the main thing, let me tell you the answer also. Here the head and the head will add, and here the head will be same. So it would be like this head plus this head will add, so it is 2a minus 2bq square. And next, this will be a minus b, q will be q by 2 here only once, q by 2 whole square. So ultimately the answer would be like 3 a minus 0.75 b q square. This would be the net head difference, h2 minus h1. Now the next question. The next question was 17th. A lot of questions. I think this uh, video will go long, so stay tuned. Okay, watch till the end. You will get all the questions. So now this was Brigham. There's similar question, same question like we that are asked in gate. What is this? This was given as shear stress versus velocity gradient and different. This is Brigham plastic. We know all. This is pseudoplastic. This is Newtonian fluid. This is dilatant. We know this was the similar question. Now the next thing is in 18th question was the condition required in orifice meter, condition of fluid flow in orifice meter, it was asked. And these options were given: plug flow, and fully developed turbulent flow, and fully developed turbulent flow, plug flow, laminar flow, and laminar flow, and one was creeping flow. Which condition is required for orifice meter to work uh, better way. So now move on to the 19th question. Uh, the 19th question was that the Darcy friction factor is 4 times of fanning friction factor. Uh, in or in even in Renault greater than 10 lakh something. So this was the question, a little twist, but this was true. And 20th question was that in a rotameter, so the force of gravity Fg is equal to Fd, force of drag plus force of buoyant force. So this was the thing, because we can see a rotameter like this, where this goes up like this. So the drag force and buoyant force are balanced by the gravitational force. Simple. Now the 21st question was again on rotameter. It was not on rotameter. We had to there were 4 options given and we have to select the correct option. So the right option was that rotameter was is arranged in vertical direction, direction where the fluid goes from bottom to up. That was the right answer. uh, the options, if anyone knows, then I will request they can write down in the comments. 22. Now there was one very good question. I'd really like this question, that uh, it was a packed bed, okay, and there was like this packed bed, like there were this catalyst assumes, let's say. So